This is a review of the Keysight E36313A triple output power supply. It's an expensive power supply. It's around $2,000, but it has some features that set it apart from a lot of other power supplies. And if they worked properly, they'd just be awesome. The features are, it'll measure currents down to the microamp range. It has built-in data logging and also a built-in graphical display for data. It does output sequencing so that you can have outputs come on in a certain order. All those features are exactly the kind of thing that I'd like to have in a low power, in a power supply for low power design. But the firmware is absolutely terrible. And I'm going to spend this review talking about the firmware. If I'm not going to do a hardware teardown, the EEV blog or the Signal Path just do an absolutely awesome job, much better than I could do at assessing what's in the hardware. So there is no teardown here. It's just going to be a firmware review. This is brand new as of December 2017. It's running the current firmware 104-100-104. It's got an enormous number of bugs. I own a lot of HP Agilent Keysight gear, and I've always been happy with it. And this is the first piece that I'm just completely unhappy with. To start, there's a number of crash bugs. I'll demonstrate a couple of those. First one, so power on. One of the very nice things is it does power on very fast. There's not a lot of wait time. So first crash bug is there's a store recall button. Hit store recall. It brings you to a menu. Hit back again. And now the display is no longer updating. None of the keys work. Everything is completely, entirely wedged and hung, including the power button. Power button does nothing. Since there's no hard on-off switch, the only way out of this is to unplug the supply and start again, which I'll do right now. So let me demonstrate another crash bug. For pretty much any free text input field, I'm editing the one for the file name for a screenshot. There's a buffer overflow issue. One of the things I don't like about this right there that says screenshot.bmp, if you just want to change that to screenshot1.bmp, there does not appear to be a way to edit that. Instead, when you say enter on this, it brings up something that makes you type the whole file name from scratch. But anyway, what I'm going to do is I'm going to make a long file name, and we'll see two GUI issues here. So let me just repeat this. And the first thing we'll see is the characters scroll right out of view, so they extend beyond that. And if we just keep going, all of a sudden we get to a point where there's no more responses, and in fact the power supply is completely hung. So just like the original crash bug I showed you, that's another crash bug. Again, the only fix is to unplug it and plug it back in, so I'll be back in a minute. So a more troubling problem has to do with the rotary encoder for setting voltage. Each detent of the rotary encoder for voltage increments the set voltage by 1 millivolt. The problem here is that there are jumps, and sometimes the jumps are small. 3 millivolts is really common, but sometimes they're large. I've had jumps for a single detent that are 700 millivolts. I'm going to turn the rotary encoder knob really slowly so we can see it in the video, but it tends not to make much difference how fast you turn the knob. So there was a jump right there. So you saw it go 0, 1, 2, 133, so 130 millivolts. And sometimes, even though it's a turn to the right, the jumps are negative. Let's see if we get one of those. There's 150, so we jumped another 20 millivolts. There's another 17 millivolt jump. We might not get any negative ones here. We jumped another 100 millivolts there. Anyway, that sort of makes the power supply unusable for if you're gonna, zero in on where a comparator triggers or something like that. So there are other odd behaviors with the firmware that kind of undermine my confidence in the quality. For instance, back in the rotary encoder, notice we're at 0 volts as a set voltage. If we bump that up to 1, by rotating the rotary encoder, and then we can bump it back down to 0. It behaves as expected, but if we bump up to 3 or so, I just had a jump, so it went up to 5, but now if I try and get back to 0, I can't get there. So I'm stuck at 1. However, if I jump up to a couple hundred millivolts, and then head back for 0, I can now get to 0, but I can't get to 1 anymore. So, being able to get to 1 millivolt doesn't mean anything to me. It's not particularly valuable. It's just kind of interesting that there's these odd behaviors. There are a bunch of them. I'll demonstrate a couple more. Okay, I want to say one more thing about the rotary encoder here. The rotary encoder nominally increases 1 millivolt per detent. So to get up to a large value is a lot of little detents. So what they did is sort of a mouse acceleration kind of thing. If you turn it a large amount, you jump quite a bit. So there's 300 millivolts, there's 700 millivolts. This approach works fine for oscilloscopes and stuff, where you don't care if you sort of go over and you can get back at it. But I don't like this at all for a voltage source, because I want to get to 1 volt. And I don't know how much I have to turn this to get there, and then the increment is so small. So it's kind of like Wheel of Fortune or roulette wheel. It's give it a spin, see where you end up. So I just peeled off 800 millivolts. I just put back on 5. I don't like that at all. I would be much happier having like the up-down arrows here that incremented in time, or even having this so that it did something predictable, so that if after 10 detents it starts going up by a factor of 10 millivolts or 100 millivolts or something. But they didn't do that. It seems to be purely based on acceleration. I don't like that at all. So another special feature of the power supply is this ability to have an output list, a list of currents and voltages that you can sequence through over time. Unfortunately, the implementation here is also buggy. So here's the list. Right now there's no entries. I'm just going to add a couple blank entries. So add. So there's 10 entries. Now I'm going to clear them. Cleared all the entries, and notice the first line is blank. Let me add a line, and it's blank too. Let me add another line, it's blank too. And I can't edit this. So I can type at it, but nothing happens. The only way I found to correct this is power cycle. So we'll do that. So the power supply has 3 features that I really want to love, and they're the reason that I bought the power supply. The first one is that it measures down to microamps. That would be invaluable if it really worked. The other 2 are data logging and data display. We'll get to those in a second. Let's talk about the microamps first. So first, notice that here on channel 1, with nothing connected, so there is, the outputs are not on, and there is nothing connected. It says that I'm sourcing 46, 47 microamps. I'm okay with that. I can, do the math in my head to knock off a few microamps, if in fact that was correct. Interestingly though, when I go to turn off, let's see if I do this correctly. There we go. So when I go to turn off or change the resolution, notice right now it says sourcing 47 microamps. I'm going to flip off the range switch here and say just tell me in milliamps, and all of a sudden I am now sourcing minus 0.1 milliamp. So I'm syncing, it says now on this range I'm syncing a milliamp, but if I go back to the low range it says I'm sourcing 49 microamps. I don't know what to believe here, because really there's no current flowing to any external circuit. So I don't even know how to do the correction to get the data that I'm interested in. Now the next interesting bit is I'm on channel 3. If we look on channel 3, it says that I am currently sourcing 5 microamps. I do have something connected to that, but it's just this alligator clip that's doing absolutely nothing. And what I'm going to do is short that together. So notice the 5 microamps, and watch what happens when I just short this. All of a sudden it's syncing a full milliamp. 970 microamps. Now, yeah, there may be a little bit of galvanic action, or maybe I do have an unintended thermocouple or something, but I kind of doubt that I'm sourcing, that much current. So that's kind of suspect, but let's take that one step further. So what I'm actually going to do is I'm going to now short this channel, and I'm going to actually drive some current, so source some current. So I'm going to set the current to 0.1, so 100 milliamps. I'm going to crank the voltage on down. Actually, no, let me set the current smaller, 0.001. So that's the minimum current. I'm going to turn the channel on. So the channel's now on. I now see that it says I'm sourcing 1.300, so I got 4 significant digits. What I'm going to do now is slowly increment the current. Now I have 5 significant digits, and they all look, I haven't measured them for precision, but there are 5 significant digits being displayed until I happen across 20 milliamps. So shortly after I cross 20 milliamps, it shifts to the other scale, and now I only have 2 significant digits. So now the precision with which I can tell what my current change is plus or minus 5%. A second ago, I had plus or minus, let's see, that's 1%, 1/10 of a percent, 100th of a percent. So this notion of measuring down to the microampere range is kind of useless if you're going to do something that's up at 20 milliamps. So one of the nice features about the power supply is that you can do output sequencing. You can sequence the individual outputs to come on some time delay with respect to one another. Unfortunately, the GUI for doing that is just fine, but when you actually do it, it gives you some unexpected results, or at least unexpected to me. So what I have here is I've set up channel 2 to have a delay both on and off. So when I turn the channel on, there's a 2-second delay indicated here, and when I turn it off, there's a 5-second delay. And then I put an LED on the channel 2 output sitting right there, and what I'm going to do is I'm going to turn all channels on, and we'll see that it takes a little while for that to come on. There's our 2-second, the LED lit. Notice the channel light came on. The difficulty I have is when I turn them off, I will still be sourcing current. The light will go off immediately. I'll still be sourcing current though, so the LED is going to remain on for 5 seconds. So I have no indication that the power supply is still supplying power, even though it's still sourcing current. Let me do that again. It'd be much better if either this light stayed on, or if it blinked, or if it dimmed, or if it did something to give me some kind of indication. Now, another reason that I bought this particular power supply is I do like to be able to see what when the magic smoke leaks out, what just happened. So this notion of having both the data logger and the graphical display is tremendously attractive. Unfortunately, the way it's implemented is that you cannot run it without a USB device plugged in. All my data is not so precious that it needs to be preserved in the annals of human history. I really would just like the power supply to, display what just happened. So I don't know why I have to plug in a USB device, but let's do that. So the first USB device I tried, which was just laying on the bench, noticed that the displays are all updating, and by the way, the outputs are all working. When I plug in the USB device, the displays stop, and the outputs stop, and nothing seems to be working. Interestingly though, it's not fully hung. When I unplug the device, all of the keyed up things come back to play. So let's do that again. So I'm going to plug in the memory stick. The memory stick, by the way, is there's nothing special about it. It's just a small memory stick. It's formatted correctly and everything. Reads fine in a PC. I'm going to unplug it. I don't get it. Let's try a different memory stick. So before I go to the new memory stick, let's see if under utilities, if there are any errors reported for that USB stick. No. And in fact, I've never seen an error reported despite all the crashes I've had. I've checked the error log frequently, so I don't know what constitutes an error. Maybe just a calibration, or maybe just a self-check error. Okay, new USB stick. That's looking better. Let's try the data logger. Okay, I'm going to only care about channel 3, so let me turn these others off. So now we're looking at channel 3. Let me start the logger. So, oops, not what I intended to do. Run the logger. There we go. Let me turn the output on. Let me scale this. Well, interestingly, auto scale, I don't know if auto scale is toggling or precisely what that's doing. Let's let that run. Logging complete, done. So we should have a file. Interestingly, the logging is not open-ended. You have to specify just exactly how long you're gonna log for. It'd be nice, you can probably crank it up to hours. It'd kind of be nice to just have a scrolling window. But let's look at the log file. So it turns out that the log file that's written is a mix of, it's a binary file. It looks like it'd be pretty easy to decode, but you actually have to convert the file. So let's try that. Interestingly, it's going to output it to a name, so let's go back for a second. The log file, you can say append the date and time to the file name, but when you go to export it, you can't. So that means it's just going to overwrite it. It'd be nice to have that option here, or to allow me to easily edit that path, or easily edit that file name and call it default 1. I'd much rather be able to say auto increment or append the date. So let's export the data, and now we'll go take a look at that. So I've exported the data, but then it occurred to me that I want to find out if it gives me a warning about I'm about to blow away my data, because I may have precious data on here that had the default name. So if I just hit export again, it just says exporting. So no warning, no automatic renaming. I'm not happy about that. Okay, so here's the data, and annoyingly, the time is not a column. So they actually make you do the math from the sample interval and the number of samples and all the rest of that to get the time on it. I don't know why that's necessary. It would, if you got to convert it, why don't you just put the time fields on there? So here's another one. I'm going to set the current on channel 3, the channel we were just working on. So under source settings, I'm going to set the current here. So I'm going to cursor to the current. I'm going to enter 0, enter. And I get a pop-up message that says data out of range channel 3 current 0.00 to 2.06. Well, okay, let me try 0.00, enter. Data out of range channel 3 current 0.00 to 2.06. Okay, I give up. 0.0, same thing. Turns out that the lower limit is actually 0.01. And if I do that, or 0.001, if I do that for current, I can get there, but that's just the error message is wrong. Interestingly, back on the main page, if I try and enter that current here, 0.0, I get a very similar looking, whoops, let me hit current, 0.0, enter. I get a very similar looking message, but it's correct. It says range is 0.0012. So kind of odd there. Now another misfeature, the glossy also makes a point of saying, you know, oh, there are two knobs, and you know, customers wanted that. They wanted a current knob and a separate voltage knob. I think every other piece of equipment I have has a multifunction knob which will edit the field, which will adjust whatever field you have highlighted. So this notion of having a separate current and a separate voltage, I'm not really getting it. But one of the liabilities with this is these are functional. So my brain is programmed to, you know, try and adjust a field by cranking a knob, And one of the liabilities here is if you are not looking at the channel for some reason. So let me demonstrate. If I go to user settings and I go to, you know, date and time, and I'm going to change this year again. If I just start cranking on the voltage knob and nothing's happening, hey, you know, what's going on here? Why doesn't this channel work? Well, if I go back now and look at my voltage, I have in fact cranked the voltage around. So it's completely blind that, you know, I can change the voltage without knowing what it is. I think a much better thing to do there would be to, you know, beep at me if I change this, or to jump me to a screen, or to pop up a window, or anything. Give me some kind of indication that, you know, hey dummy, you don't want to do this. This, between my programming of, you know, needing to turn a knob to adjust a value and the fact that it does it hidden, that's going to sting me. Now, another feature that they built in here that I'm kind of mixed on is the built-in self-help, which I'm all for. So hold the button for an extended duration and you get a help menu. A couple problems with this are a lot of the items are not at all helpful. So for instance, there's one thing that, you know, I don't remember what it does. Let's see, and I'll demonstrate. So under, I think it's under IO config, whoops, sorry. Under, let's back on out, under output settings, there's output coupling. I just don't remember what that was, so let me hold this button for group 1 channel 1 coupling, and it says enables or disables output coupling for output 1. Okay, that wasn't very helpful. Now, a long press on a button is how you get the help, but there's also other buttons that long press means something different. So for instance, if I want to know what tracking is, long press on the tracking actually turns tracking on. I wish there was some consistency here. A long press on meter view will actually do a screen capture instead of telling me what meter view is about. And, you know, that's kind of a weird function to put on that, because if I press meter view, it just changes the display. So I don't think I would intuit that holding meter view will do a screen capture. Other buttons will either repeat, like number buttons. Incidentally, the number buttons have a larger buffer than the precision of the device. I don't know why we did that. So buttons that do repeat, like the cursor keys, interestingly, there's an input buffer, so I'm just going to hold this, and what we'll see is it's going to buffer up a bunch of events, so I can't stop when I intend to. And you'll also notice that they're not perfectly periodic. And you hear this? Hear it slow down. And when I take my finger off, it keeps going for, you know, 6 or 8 or 10. So I don't know why the type ahead was necessary. Very interestingly, I expected when I started having power hangs, I expected that maybe the power button would do what it does on a laptop, which is if you hold it, it will force a shutdown. But interestingly, that's a repeating button. So whether or not when I take my finger off the power is on or off appears to be a crapshoot. So that was a power off. Interesting, I guess, you know, interesting. So there's several ways to move the entry point around, or the entry field around. So the channel selection, these buttons up here, will actually move the entry point like this. Turning a knob, turning either the voltage knob or the current knob, will move the entry point. You can see this move as I turn the current knob, or turn the voltage knob. But there's also these cursor buttons down here, left, right, up, and down. And they behave differently on different screens, which I think was accidental, and it's certainly counterintuitive. So on this screen, they do what you'd expect. They go across the row and down the column. But they also cycle across those. So if I go across the row, it'll cycle to the top of the next row, right? So pressing just one button will hit all the entry points. And doing it in up and down does the same thing as you'd expect. But if we go to a different screen, those buttons behave differently. So if we go to source settings, which is just a different view, now all of a sudden the left and right button only toggle on this row and don't get me to all the entries, whereas the up and down buttons do get me to all the entries. It's kind of confusing. Now let's go to yet another screen. Let's go to the date entry field, which is under test setup, user settings, date time. And here, the left and right buttons go across the fields as you'd expect, but the up and down buttons increment and decrement the fields. I like this particular form much better. I can get to all the fields. The most fields that any screen has is on the order of 7 or 8. So it's not a major pain to get across the fields. And I like the ability to hold a button and have things change. And it does repeat in a predictable way. I like that entry a lot better. One thing that I don't like, though, is as you hold a button, it buffers it up. So my finger's off the button. I'll demonstrate that someplace else. Something else I don't like is there's no way for me to get out of this now. So I don't want to save that change. It's not 2013. I just want to abort this. There is no escape button anywhere. There's no abort. And if I just say back, it doesn't let me out. So if I, for some reason, didn't know the time and I had changed the time field, now I'm stuck. I can't abort. And interestingly, no, I take that back. What I just did there was I hit a channel button, and let me see if it lets me out now. Yeah, now it lets me out. So I guess the channel buttons, are equivalent to an abort. I don't think that's documented anywhere. So a lot of power supplies will calculate the instantaneous power for you, the product of the voltage being sourced and the current that is flowing. But for low power design, I would much rather, instead of having instantaneous power, that's kind of useless to me. What I'd rather have is the energy delivered to the circuit since I enabled the channel. So watt hours or milliwatt hours. The reason is a lot of low power designs run at high intensity for a short time and then sleep for an extended period of time. And when you're tuning that, it would be nice to know over the duration of some relatively long cycle, a minute or whatever, what was the power that I delivered to the circuit. Because the peak instantaneous power doesn't, the peak instantaneous power might be high. Same thing for transmitters. You may transmit for a short duration at high power, but then be idle or be in a standby state for a long time. I'd really like to, when I'm optimizing power, how much life I'm going to get out of a battery, I'd really like to know how much energy did that, unit of work take. So there's another feature that I'd really like to have in a power supply for low power design, and that's when a channel is off, I'd really like the channel to be an open circuit to my circuit. That's not commonly what's done with power supplies. There's a bleeder resistor across here, or I assume it's a bleeder resistor, that sinks some current from my circuit at 4 milliamps or so. A worse feature, as far as I'm concerned, is when the channel is off and the output is discharged, the filter caps inside are discharged, and you connect your energy storage circuit to this, the power supply will sink an enormous amount of current when it charges, as it charges its filter caps off of your circuit. I'll demonstrate that later. So the bottom line is that Keysight has a really good bead on exactly what I would like to have for a power supply for low power design. And that the microampere range, the plotting, the sequenced outputs, right on the money. Unfortunately, the firmware is so atrocious that this is just absolutely unusable to me. And I think that the level of effort to get it to usable is going to be a pretty extensive firmware rewrite. I've submitted a number of bugs to Keysight. I expect that they'll release something for the more egregious errors, the hang bugs, but I kind of doubt that they're going to have the will to rework the firmware to the point that this would be an awesome power supply. I think that that's just tremendously unfortunate because this is so close. If this review is useful to you, please let me know. I'd also be willing to review some of the other pieces of equipment I have that I just absolutely love. And just let me know. Thanks. Bye.